You know that feeling, right? It's Friday afternoon, you've just pushed a big release, the team is celebrating, and then your weekend gets completely wrecked by some tiny, hidden bug that nobody caught. We have all been there. Well, today, we're going to dive into how AI is fundamentally changing that entire story. It's becoming less of a futuristic concept and more of a powerful new partner in our ongoing battle against messy, buggy code.
I mean, this quote just hits home. It's that gut-wrenching feeling when a memory leak that only appears under heavy load or a brand new CVE in one of your dependencies suddenly grinds your entire production environment to a halt. This is the exact problem that code auditing has always been trying to solve. But let's be honest, the old ways of doing things, they have some serious limitations.
And this slide really lays out the massive shift we're talking about. On one hand, you have traditional auditing. It's often manual, it's painfully slow, and it's based on a rigid set of rules. You know, like a linter that yells at you for using single quotes instead of double. It has its place, but it can be so noisy and inflexible. But then you have AI auditing, which just completely flips the script. It's automated, it's lightning fast, and this is the most important part, it's context aware. It doesn't just see a rule violation, it understands the intent of the code. It sees a pattern. So let's really dig into this new paradigm. Because over the last few years, these AI auditing tools have evolved from being kind of experimental toys for early adopters into seriously powerful production-ready systems. They're not just a novelty anymore, they genuinely promise to change the way we find, understand, and fix problems in our code, for good.
So what are we actually talking about when we say AI-powered code auditor?
Well, at its core, it's any tool that uses machine learning or, more recently, large language models to analyze a codebase. But here's the key difference. Unlike a traditional tool that just flags a rule violation and says bad, an AI auditor might look at your code and say, hey, this variable name looks like a user's private key and it's being used in a logging statement. You might be about to leak sensitive data into your logs. See? That's a whole different universe of insight.
And this right here gets to the heart of why you should really, really care about this. First, there's the sheer scale of it. An AI can chew through an entire monorepo, millions of lines of code, in the time it takes you to go grab a coffee. That's not days of manual review, it's minutes. Second, you get real context. It doesn't just flag an error. It explains why something might be a problem, often with examples. And finally, you get this idea of continuous auditing. It's like having an always-on, super intelligent pair programmer watching over your shoulder from the very first commit all the way to when your code is running live in production.
Okay, so with all these new tools popping up everywhere, it can feel a little overwhelming. The best way to think about it is like a brand new, specialized toolbox for developers. Each tool has a specific job. So let's open up this toolbox and break down the major categories so you'll know exactly which tool to reach for in any given situation. First up, we've got the one you've almost certainly heard about and probably even used, the LLM-based code review assistants. Think of these as your AI copilots. They live right inside your IDE or your pull request workflow, things like GitHub Copilot or Amazon Code Whisperer. They're designed to feel less like a tool and more like an expert senior developer you can just chat with. And their biggest strength, by far, is that they're interactive. You can literally ask them questions in plain English, like, hey, can you explain this complex regex to me? Or is there a more efficient way to write this function? This makes them absolutely fantastic for onboarding junior developers because they act like a patient mentor. And because they're trained on vast amounts of public code, they're incredibly flexible and can jump between Python, JavaScript, Go, you name it, without skipping a beat. Now, while those LLM assistants are great for that interactive, back-and-forth conversation, sometimes you just need a silent guardian, a more systematic, automated process that runs in the background. That's where our next tool category comes in. This is all about taking the traditional static analysis tools many of us already use, like SonarQube, and basically supercharging them with machine learning. Think of tools like DeepCode, which is now a part of Snyk. The key advantage here is all about precision and noise reduction. By learning from millions upon millions of open source projects, these tools get really good at telling the difference between a real critical bug and a minor style issue. This is huge because they can help you prioritize. Instead of showing you 200 warnings, they can say, hey, out of all this noise, these 3 are the ones that are actually going to cause a production outage. And the best part? They slot perfectly into the CI/CD pipelines you already have, running automatically on every build. All right, let's shift gears and focus squarely on security. This next category of tools is a big deal. They don't just look for known vulnerabilities that are already in a database somewhere. They use AI to try and predict new, undiscovered vulnerabilities before they're even documented. This is about moving from reactive defense to proactive defense. And honestly, this is a total game changer for security teams. These tools can spot patterns in code that are often associated with things like SQL injection or cross-site scripting, even if it's a completely novel attack vector. It's like having a security researcher that never sleeps. As attackers get more sophisticated, these tools adapt right alongside them. This makes them absolutely essential for anyone working in high-stakes industries like finance or healthcare, where compliance and security are non-negotiable. Let's be real. Every modern application we build is standing on a mountain of open-source dependencies. And while that's amazing for productivity, it can also be a massive, silent threat lurking just below the surface. This next category of tools is designed specifically to audit that entire mountain for you.
So here's the critical difference. These tools are proactive. Instead of just waiting for a formal CVE to be published, tools like Snyk's Dependency AI can analyze the behavior of your packages and predict which ones are likely to be risky before the rest of the world knows about it. This automates what is otherwise a huge manual burden of tracking dependencies, and it's an absolute must-have for any project that pulls in a lot of open-source code.
Of course, we all know that not every bug can be found just by reading the source code. Some of the nastiest issues, things like race conditions, deadlocks, or subtle memory leaks, they only show their face when the code is running live, in the wild, under real-world stress. And that's where our next set of tools comes in. This is where AI meets observability, and it is incredibly powerful. Tools like Datadog Watchdog or Dynatrace's Davis AI are constantly monitoring your live application's performance. They detect anomalies and weird behavior, but here's the magic part. They can trace those runtime problems directly back to the specific lines of code or even the specific commit that caused them. This ability to connect a live production fire to the exact code that started it is just invaluable. It can slash your debugging time and drastically reduce application downtime. And finally, we have the big guns, the hybrid platforms. You can think of these as the all-in-one, whole shebang solutions. They try to do it all, combining static analysis, dependency scanning, vulnerability prediction, and sometimes even runtime monitoring, all into a single unified platform. The main appeal here is simple: comprehensive coverage. By looking at everything from your source code to your dependencies to your container configurations, these platforms aim to eliminate blind spots. Now, they're often complex and they aren't cheap, but for large enterprise organizations that need that single source of truth with powerful dashboards and C-level reporting, these hybrid systems are often the go-to solution. Now, as incredible as this whole toolbox sounds, we need to have a very real conversation. AI is not a silver bullet. It's a powerful tool, but it's not magic. It's really important to have a balanced perspective and understand the trade-offs before you just dive in headfirst and integrate this into everything. So on one side, you've got some very real challenges. AI tools can and do produce false positives. They might flag perfectly safe code just because it doesn't match a common pattern, and that can lead to serious alert fatigue where you start ignoring everything. Then there are the privacy concerns. When you use cloud-based tools, you're essentially sending your company's secret sauce, your proprietary source code, to a third party. That's a huge consideration. And finally, there's the risk of over-reliance, where we might stop honing our own critical judgment and just blindly trust the machine. But you have to weigh those challenges against the massive opportunities we've talked about: the scalability, the deep contextual insights, and that continuous 24/7 monitoring. These are advantages that are just too significant to ignore. So with all of this in mind, how in the world do you actually choose the right tool? Well, the key, like with any toolbox, is to match the tool to the specific task at hand. You wouldn't use a hammer to drive a screw. So let's walk through a few common real-world scenarios to make this really concrete. Think of this table as your practical guide. Let's break it down. Say you're a startup building an MVP. What's your primary need? Speed and quick feedback. So an LLM assistant like Copilot is a perfect fit. Now, what if you're a big enterprise in a regulated industry? Your main drivers are auditability and bulletproof security. In that case, you're looking at the heavy-duty hybrid systems or the specialized vulnerability predictors. Running a popular open-source project? Your biggest headache is probably managing that mountain of dependencies, so an AI-driven dependency auditor is your best friend. And finally, if you're a SaaS company that's starting to scale up, your focus is on stability, both in your code and in production. That's a perfect use case for combining ML static analysis with an AI runtime monitor to cover you before and after deployment. Ultimately, if you take only one thing away from this, let it be this. The future isn't about AI replacing developers. It's about partnership. These tools are here to augment our skills, to be our co-pilot. They handle the tedious, repetitive pattern matching work so that we can focus our uniquely human judgment on what really matters: architecture, creativity, and solving the truly hard problems that machines can't. So AI code auditing is no longer some far-off futuristic concept. It's a real, practical set of tools that you can add to your belt today to make you a better, faster, and more secure developer. The real question isn't if you should start using it, but how and which one fits your needs. So as you think about your own projects and your own team's workflow, which AI partner are you going to choose? And what are you going to build with it?